In this video, we'll be evaluating definite integrals using substitution. Find the exact value of the definite integral without using a GDC. When necessary, first rewrite the definite integral using a U substitution. Check your answers by finding the value of the definite integral on your GDC. A. Integrate the function 3 sine x dx between the limits 0 and pi over 6. First, rewrite the equation by taking the 3 outside the integral, giving us sine x dx between the values 0 and pi over 6. Now we can integrate the function, getting minus 3 cos x between the values 0 and pi over 6. Now put the two values into your equation, giving us minus 3 cos pi over 6 minus cos 0. Cos pi over 6 is equal to root 3 over 2. Cos 0 is equal to minus 1. So we get minus 3 times root 3 over 2 minus 1, which is equal to 6 minus 3 root 3 over 2. In this case, we did not need to use U substitution. Part B. We're going to integrate the function 3x squared plus 1 to the power of 3 times 6x dx between the limits 0 and 1. We're going to use the substitution u equals 3x squared plus 1. So we'll differentiate u, getting du over dx equals 6x. Rearrange to find dx. So dx equals du over 6x. Because we're going to change our equation, we also need to change our limits. We do this by substituting 0 and 1 into the equation u equals 3x squared plus 1. When x equals 0, we get u equals 3 0 squared plus 1, which equals 1. When x equals 1, we get u equals 3 times 1 squared plus 1, which equals 4. Now we can substitute all the new values into our original equation, getting the integral u cubed times 6x times du over 6x between 1 and 4. As you can see, the 6x's cancel, giving the integral u cubed du between the values 1 and 4. We can integrate this, giving we evaluate u to the power of 4 over 4 between the values 1 and 4, substituting 4 and 1, giving 256 over 4 minus 1 over 4, which equals 255 over 4. Part C. Integrate cos x sine squared x dx between the limits pi over 4 and pi over 2. In this example, we're going to use this U substitution. U equals sine x. We're going to use that substitution because sine has the largest power. Differentiate u equals sine x to get du over dx equals cos x. Rearranging to find dx. Dx equals du over cos x. Again, because we're going to alter the original equation, we also have to alter the limits. So we're going to substitute pi over 4 and pi over 2 into the equation u equals sine x, giving when x equals pi over 4, u equals sine pi over 4, which equals root 2 over 2. When x equals pi over 2, u equals sine pi over 2, which equals 1. We can now substitute everything back into the original equation, giving the integral cos x times u squared times du over cos x, and again the cos x's cancel, giving the integral u squared du between the values √2 over 2 and 1. If we now integrate, we get u cubed over 3 between the values √2 over 2 and 1, which when we work out gives us 4 minus √2 over 12, which equals 0.215 to 3 significant figures. One final thing, you will get the same answer if you change the antiderivative back to terms of x and evaluate with the original limits given in terms of x.